All right, hello YouTube people. This next tutorial is on linearization of data. So what I've got here is some measurements where we change that and we measure that and we take our average as we normally would. Now I've made this data a certain proportionality, and in most cases you will know what the proportionality is. I am recording, yep, cool. So really, you're basically confirming what you already know, but this data could be unknown for all you know. Now, normally, that should say Y values. Normally, your Y values, you change your X values and you measure Y. In this experiment, we may have changed that and then measured time, but we might want to have a YX graph for reasons that will make sense in just a moment. So we'll go insert scatter plot. And we'll start off with our blank, because remember when you highlight the text, it normally puts the first values in the X column. So I'm going to manually select the data, add a series, highlight my X values to be X, and then highlight my Y values to be Y. Now, this obviously is not linear. We could try and add a line of best fit, but it would be very, very silly to do so. Because it is clearly not linear. So let's undo that jazz. So the question is this a quadratic? So the question is, if I plotted x squared, would I get linear data? So let's have a look. We're going to go equals bracket our x values to the power of 2, and I'll drag that coding down. Okay. I'm going to ignore precision for now. I don't have time to muck about with precision. So now, if I just go back into select data, I'm now going to edit that series, and instead of column E, I'm going to highlight column F. Pressing enter, it looks a little bit better, but still there looks to be a little bit of a curve. And if I was to change my axes, that curve might be a little bit more pronounced. If I add my trend line, and obviously we want our equation and our r squared. If we add the trend line, we see that the middle data is below and the first and last two dots are above, which again, that's telling me that this is probably a curve. It does have a strong correlation, but still not really confident with that. So let's go one step further and then go, is this a y proportional to x cubed? Is this a cubic function? So we're going to go our coding, try that again. We're going to go equals time to the power of 3. We'll drop that coding down. Okay, so we're cubing our time values. Again, I'm going to select data and I'm going to edit my series that my X values are now the G33 to G39. Press enter and this looks a lot better, okay? And in fact, I did fudge this data so that it was a cubic. You could go one step further and ask, is it x to the power of 4? But it actually isn't. What would happen is it would curve the other way, and it would start looking like a fractional power, like a square root function. The reason this dot might be a little bit low is it going to bring up, so point number 4, that 8.61, I may have done the time 2.05, that might be a little bit low. So if I was to fake this, I want to bump that up a bit. So I might go 2.03. Oh dear, what have I done? Control Z. 2.03. I might bump this one up to 2.10. No, I seem to not, that's not really doing anything. Did I want to up time? Well, I don't know what I'm doing there, so I'm just going to go back. Obviously, this data point is a little bit off because I just made a little bit of natural variance so that we got a little bit of a scatter. A correlation of 0.993, that's spot on. That is definitely, that data matches the equation y equals 0.4935 x cubed minus 0.0063. And for those of you that are playing at home, the actual equation that I had in mind was y equals a half x cubed plus nothing. And so that tiny little variance was me just sort of upping the time and lowering the time to produce a little natural variance. So if you compared 0.493 to 0.5, we're nearly there. It's like a 49.3 compared to 5. You're looking at 1.4% error in that gradient. And then obviously 0 to 0.006, that's less than 1% error. So that was just me playing around with this raw data over here. I just sort of upped and lowered them and increased them a little bit to give that variance. Okay, so hopefully you have found this tutorial beneficial on the linearization of data in experiments. See you all some other time.